Okay, so on to the product rule and the quotient rule. These are two rules that most people seem to be doing really well with, and so I think we can go over this rather quickly. The product rule is what you're going to use when you see a function defined to be two other functions multiplied together. So f of x times g of x. And a lot of times you're not going to put the dot won't be given to you explicitly. You just need to know when you're multiplying the functions. So the product rule says the derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. One more time. If I have two functions being multiplied together here, then the way I take the derivative is it's the derivative of the first function times the second function plus the first function times the derivative of the second. We also have an extended product rule that's going to work if you're multiplying three functions together, or four functions, or five functions. The way that it works, if you have f of x times g of x times h of x, the extended product rule says you take the derivative of the first function times the second times the third, plus you leave the first function alone times the derivative of the second times the third function, plus leave the first two functions alone. So it's the derivative of f times, I'm sorry, not derivative of f. It's just f times g times the derivative of h prime. So one more time, I have three functions being multiplied together, f, g, and h. The derivative, it's going to be f prime times g times h plus f times g prime times h plus f times g times h prime. And you could expand that to the product of four functions, five functions, six functions, but as long as you know how to extend it to three, you're probably good. All right, then we also have the quotient rule. Quotient always means division. So if I am dividing two functions, I have f of x over g of x. The quotient rule is g of x times f prime of x minus f of x times g prime of x over g of x squared. For students in my classes, we have talked about the high and the low. F of x is the high because it's in the numerator. G of x is down low. It's in the denominator. And the song goes like this. It's low d high minus high d low over low low. It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So one more time. Low d high minus high d low over low low. All right, let's actually put this to practice. This first example, f of x is x cubed minus 4x times 5x squared minus 9. So x cubed minus 4x is the first function. 5x squared minus 9 is the second. I'm multiplying those together, and I want to find f prime of 0. In order to do that, we're going to use the product rule. Product rule says take the derivative of the first, which will be 3x squared minus 4, times the second, plus, now we leave the first one alone, times the derivative of the second. That's going to be your derivative. 3x squared minus 4 times 5x squared minus 9 plus x cubed minus 4x times 10x. Great. Now we need to find f prime of 0, which means everywhere there's an x, we're going to replace x with 0. 3 times 0 squared is 0, minus 4 is negative 4. 5 times 0 squared is 0, minus 9 is negative 9. Plus 0 cubed is 0, minus 4 times 0 is 0, times 10 times 0 is 0, and we get 36. So f prime of 0 is 36. That would tell me that the slope of the tangent line at the function f, the slope of the tangent line to f at x equals 0 is 36. I could also say that because The slope of the tangent line is positive. The function is increasing, right? These are all ideas from old units. That's good stuff. Second one, we've got the derivative of 5x minus 2 over x squared plus 1. It's a quotient rule. The high is 5x minus 2. The low is x squared plus 1. So we're going to take the derivative by doing low, x squared plus 1, times d high, derivative of the numerator, minus 5x minus 2 times 2x over x squared plus 1 squared. Low d high minus high d low, low low. You could stop here and not worry about simplifying, but since I've got lots of room, let's actually go further. X squared plus 1 times 5, I'm going to distribute the 5 through and get 5x squared plus 5. Minus, I have 5x minus 2 times 2x. 5x times 2x is 10x squared. Negative 2 times 2x is negative 4x over x squared plus 1 squared. All right, I'm going to focus on simplifying in the numerator. 5x squared minus 10x squared is negative 5x squared when I combine those like terms. Minus a negative 4x is the same as plus 4x. And then plus 5. And in the denominator, I usually leave the denominator squared. So just x squared plus 1 squared. So your final answer, negative 5x squared plus 4x plus 5 over the quantity x squared plus 1 squared. That is your derivative, and that's all that you're asked to find, so let's stop. The last one that we're going to look at, we have w is a function of z. We're going to use z, we're going to use x, we're going to use theta. We need to be comfortable with all of these. So if w is equal to z squared over the square root of z plus z, and I want dw dz evaluated at z equals 9, that means I need to first find the derivative of w. That's our quotient rule. You are going to do low square root of z plus z times derivative of the high, 2z, minus high times the derivative of the low. The square root of z, if I take that derivative, is 1 over 2 square roots of z, plus the derivative of z is just 1 over square root of z plus z squared. And I need to evaluate this at 9, meaning I'm going to, everywhere I see a z, replace z with 9, and I get the square root of 9, which is 3, plus 9, parentheses 2 times 9, that's 18, minus z squared, 81. Oh boy, I can see this one's going to be ugly. 1 over 2 square root of 9. Square root of 9 is 3. 2 times 3 is 6. So 1 over 6 plus 1 over, oh, I'm supposed to have a square root there. Square root of 9 is 3 plus 9, the whole thing squared. That's uglier than I wanted it to be, but let's finish it off anyway. We're men and women in mathematics, we can do this. 3 plus 9 is 12. 12 times 18 minus 81 times 1 over 6 plus 1 is 7 over 6. 3 plus 9 is 12. 12 squared is 144. Ugh, it just gets worse. 12 times 18 is 216. 81 times 7 over 6. I can reduce that by 3 to get 2. Reduce that by 3 to get 27. We get minus 189 over 2 over 144. Okay, I'm just going to stop here. I would not ask you to do something nasty like that. It also is not the kind of thing you can expect to see happen on the AP exam. Finding that derivative is great. Plugging in the 9, great, you can do that. If you want to simplify it further, sure, you can get a common denominator, 432 over 2 minus 189 over 2. I think that's 243 over 2. Divide it by 144. you should get 243 over 288. Maybe that can be reduced. It's not important. It's not what I'm focused on right now. Make sure you know the product rule. Make sure you know the quotient rule. You're going to be just fine. All right, so before we take a little break on this part of the video, there are 4 derivatives that you really need to know. You just have to have these memorized. We went through, we looked at the graphs of 4 out of the 5 that you see here. But for the purpose of the video, what I want to focus on at this point is you must know that the derivative of e to the x is e to the x. You must, now I'm skipping that one. You must know that the derivative of the sine of x is the cosine. You must know that the derivative of the cosine is negative sine, and you must know that the derivative of the natural log is 1 over x. This one that I kept skipping over, it's not one that we've talked about much this year in calculus class, but in years past I have, in years future I might. And what this says is that the derivative of a to the x, where a is a constant, is going to be a to the x times the natural log of a. So for example, if I wanted to take the derivative of 2 to the x, the 2 is the constant, the variable is the exponent. The derivative is 2 to the x times the natural log of your base. We haven't done that this year. Don't expect that to show up on the exam, but just know that that is how you would do it, and I think I even have 1 or 2 examples coming up in just a little bit. Okay, another really important rule for us is the chain rule. This is where we talk about the baby and the mama. If you have f and g are differentiable functions, differentiable function just means that the derivative exists. Then the composition is when you have a function inside of another function, like f of g of x. The g of x is the baby. The baby lives inside of f. That's the mama. The way you take the derivative of f of g of x, we take the derivative of the mama, so f prime, and we leave the baby alone, times the derivative of the baby. You might want to say that a couple of times to yourself. It's the derivative of the mama, and you leave the baby alone, times the derivative of the baby. There's also an extended chain rule. The extended chain rule is when you have a function inside of a function, and all that is inside of another function. When we were doing problems like that, we called the h of x the baby. That baby is inside of the mama. G is the mama. But that whole thing right there is actually inside of another function. And we like to lovingly call that other function Big Mama. And the way it works when you go to Big Mama's house, if I have a baby and a mama and Big Mama, you take the derivative of Big Mama and leave her baby alone, times the derivative of her baby, leaving that baby alone, times the derivative of the baby. So one more time, it's f prime evaluated at g of h of x, times g prime evaluated at h of x, times h prime. Most importantly, know the chain rule, that the derivative of this composition is f prime of g of x times g prime, but also be ready to extend it when you have a function inside of a function inside of another function. With that, I think we're actually ready to do some practice problems, which will be in the next segment of the video.